Okay, today we're gonna get into logarithms more. They're gonna see you on video getting slapped.
It'll get a lot of hits.
Yeah, it will. Okay, look, logarithms. Listen, logarithms are the opposite of things in exponential form. So logarithms are inverses, opposites of exponents. Now, it's just a form that is written in. Let me tell you up front, the form looks funny. It's not hard though. So keep an open mind. It's just new to you. So we're going to be learning about inverses of exponents. All right. When we talk about logarithms, there's two types. There's a common logarithm. That is a logarithm with base 10. Common logarithm has base 10. When I say base 10, think about exponent, what the base is. 10 to the whatever. Same idea. Okay? So common means this. Now, when you have a problem that's a base 10, it's going to have log something. So it'll be like log will mean base 10. Okay? The other type of logarithm is a natural logarithm. A natural logarithm is base e. Now, e is just a special case of a number, kind of like pi, because pi gets used a lot and it saves time to be able to hit the pi button. Same thing with e. E is Euler's. It's with an e, but it sounds like like an O-I there. It's an Euler's number, and it's just a special number. The calculator has it. It's 2.7 something. So instead of you typing 2.7 blah 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 blah, they got the number on there. So it is just a special case. Now, when you see a natural log, it's not going to be log. It's going to be ln. That's why I'm being quick. That's okay. Thank you. I got you. All right. So it's going to have the ln, which means natural log. All right. First thing we're going to do is we're going to learn how to rewrite. We're not solving. We're rewriting, just to get used to how it looks. So this is how a log, log, looks here. And we're going to rewrite it in exponent form. Remember how we did radicals? We could take a radical and rewrite it like square root of x is the same as x to the 1/2. And y'all learned how to do that. Same thing here. We're just going back and forth. So this is log form because it's got a log in it. We're going to show it as an exponent. Now here's how we read this. This number right here is the base. This number right here is the exponent. And this number right here is what it equals. I'll just say what it equals. And you're always going to go in a circle like this. This number to this number to this number. So here's how it's going to look. The base is 2, the exponent's 5, and it equals 32. That is that in exponent form. This to this power equals this. Make a circle. It just looks funny. So what have we done? We've come up with an exponential form of this log. They're just opposites of each other. Kind of like with the radicals. You could be radical form or you could have exponent. Same idea, just a different way to look at it. This is not hard. It's just you learning where everything is at. Let's try another one. All right, here we are again, log form. We're going to put this in exponent form. So what is my base going to be here? 7. So I'm going to go this to this to this. So I'm going to have 7 to the 0 equals 1. That's all. It always makes a circle. And it's got to make sense too. 7 to the 0, yeah, it does equal 1. The one we just did a minute ago, 2 to the 5th, it does equal 32. Make sure it makes sense.
Do we have to put the 0?
Yes, it's the exponent to us. So yeah, if we didn't, it would look like an understood 1, and it's not. But that's a good question. All right, now let's go the other way. Now this one is in exponent form. Why? Because it has an exponent on it and it's not got a log on it. So I know this is exponent form. I want to rewrite it in log form now. So notice, let me flip back to the log that we just did. In log form, you're going to start out with the word, with log. So first thing here is you're going to say log. And you're still going to make a circle. You're still going to make a circle. It's going to be this to this to this. So it's going to be, here's how it looks though. Little 13, the base is little number drop like a subscript. 13 of 13 equals 1. That to that to that, always making a circle. But here's how it lies. Little base, normal sized other. Okay? That's just getting the look right. So that is log form of that. You don't have to understand really what that means right now. We're just getting used to it. Alright, so on this one, I would say log, what's my little base? 1/2, that's this, of equals, because I go 1/2 to 2 to -1, just knowing where to put them. So that would be log form of that. This is something y'all have never done. So it's completely foreign. So we're just getting used to it. All right. Next thing we look at. Rewriting, why we do that? Because it helps us solve sometimes. So let's look at one where we're going to solve. So this is one where, look, they don't tell us what it equals. On that last one, they told us what it equals, and we just rewrote it. Here, we don't know what it equals. We want to find it. So if you got one to solve, then you're going to first step go equals x. My calculus has been doing this recently. They didn't remember logs, so we had to go back over it. It kills them that I say make it equal to x. They're like, why? Because I want to find x. Well, how can you randomly stick an x? I said, I'm really just saying whatever this is my answer. So this is legit. So I can say equal to x. Once I do that, rewrite it. Let's put it in exponent form. How would that read?
3x equals 81.
Very good. It would be this to this to this like we did a minute ago. Now when you get here, then I think 3 to the what power is 81? To the 4th, he says. Very good. If you didn't know that, you could play with it. Look, in about a few days, I'll give you an easier way to figure that up. I can't right now because it's using stuff that you haven't learned yet, and so it'd take a while. So for now, toy with it. 3 to the 4th equals 81. Think about it. 9 times 9 is 81. That breaks down to 3, 3, 3, 3. So just kind of play with that part. All right, let's try another one here. Here we go. Equals x. First step. Second step, rewrite. So how's this going to read?
4x is 125.
All right. Now, seeing that we kind of got to play with this, let me see if this will help. Rewrite 0.25 as a fraction. 25 over 100, good. What, that'll reduce. 1 over 4. All right, so y'all are saying that is 1/4 really. All right, now look at this. What kind of exponent would I have to have for this 4 to become 1/4? Think about your exponent rules. Negative, very good. So x looks like it's probably going to be -1. I see you fixing to say it. Think about it. A -4 to the -1 is the same as bumping the 4 down and becoming to the positive first. So just note to self, if I start out with a whole number and it becomes a fraction, it's going to be negative. If it starts out one way and goes the other way, it's got to be negative to get to a fraction. So far, good? All right, I'm trying to give you situations here. All right, let's look at this one. Equals x. So rewrite. Thank you. All right, same idea with this one as to that one. got a fraction and a whole number. Anytime one side is a fraction, the other side's not, your answer is going to be negative. I just put that in your head. So this is going to be negative something, we know. So now, forget that it's a fraction. Just think, 4 to what power equals 256? Because we know it's negative, that's fixed. 4 to what would be 256? It's not 1, it's not 2. 4? Make sure. Is that right? Thank you. All right. So the negative accounts for this fraction, and then we just figure out how to get the 256. That's the best we can do at this point without that rule. All right. Another situation. Again, I'm hitting all the possibilities. Equal to x. Rewrite. How's it read? Good. Okay, now we don't have a fraction. They're both whole numbers. But here's the situation. It's big going to little. 49 to some power is usually going to get, think about if the power here is 1 or 2 or 3, it's getting huge. So it's not going to give me 7. What do you think is going to happen with your exponent to make this bigger number get smaller? It's a fraction. Very good. So if you got the case of a bigger number that's supposed to go smaller, it's a fraction. So x here, we know equals something over something. Now think like this. What if it was the other way around? 7 to the what gives you 49? Second. All right, what do you think the fraction is then? 1/2. That's how you can logic them out. Okay? I know it's different. We're playing with it. All right? I think I'm getting close, but yeah, this is a different situation here. All right, so now this is in exponent form. Exponent form. Yeah, it's got a log here, but look at it. Base is 11. Exponent is all that. This is exponent form. It just happens to have a log in its exponent. So when I go equals to x, help me rewrite this. Log, I'm putting it in log form. What's my base?
11.
Little 11 of x equals all of this. Because all of that is the exponent there. So log, so we went here to all of that. All right, is that, we just rewrote it, it looks funny. But that's where we're at. Now, there's a property. Let's see if you can read my mind, first period did. What do you think the property says? Look at it. If your logs are the same, you can cancel them out. Log 11 and log 11, cancel. So x, so it looks ugly, but once you rewrite it, it's actually better. All right. And I think we just got, there's 2 problems, but we're doing this one and that's it. I'm going to save the other one for later. It's a bit weird. Like Josh. But, so this will be our last one. So equals x. Let's rewrite.
2x.
Good. All right. So here now we've got the case of 2 to the what's going to equal 50. If you know, because it's exponent. So if you play around with that, it doesn't come out to be a whole. It doesn't come out to be a whole. So let's go calculator. So when you get to one that's really kind of got to be done on the calculator, there's a button under the on button. Button under the on button. Get this real quick. Type this in and let's be done. 62.08. Just type it in. All right. Thank you. I'm not giving a sign.